we are focusing on the e-commerce fulfillment market. The size of the market is in the ballpark of $250 billion. And in the last 7 years, the annual growth is 25%. We signed with the top leaders at single picking operation at United States for the first, our installation site. It will be at the end of this year. And in 2019, we will complete the second installation with one of the top 5 companies at logistics fulfillment operation that has more than 5 million square meters. So we think we validate our idea with the top players, and we're still doing this. And now we have an issue that any startup has, also this issue, it's time. So Earth is giving us 24 hours a day, so we are already working 24 hours a day, 5 days a week. And we still want to squeeze the timeline. So LEVY took full responsibility of the Gazebo project, and now we will show you how we are using this tool, what is this tool, what is the tool doing, and what are the benefits, and how we are using this each day and enjoying these benefits. So thank you guys, and good luck.
Okay, so I'll talk about Gazebo. Gazebo is a 3D dynamic simulator for robotics, and that enables us to simulate robots in a physical environment, in a complex environment, and multiple robots. So this is a brief about Gazebo. I'll show a few short videos of Caja. This is from a live demo in Shanghai that we did for 4 days. So this is our forklift robot picking a box. You will see it picking a box. So we have one big forklift robot and multiple robots like this going around in the aisle. And we have a small robot that can pick only from the first floor. We'll see it in a minute. Okay, you hear me? Okay. So, so this is the live demo from Shanghai, and I'll show the. Okay. This is our small robot that can pick from the first floor, and he's a lot faster. So both robots we can have. If we have a big warehouse, so we can have hundreds of robots like this and like the big one, collaborating together, taking goods from the warehouse and out of the warehouse to the picking station. All is autonomous. Okay. I'll show a short video of highlights of Gazebo, just so you'll have the feel what can we achieve using Gazebo. And you have some info on the side. This is all Gazebo. All is a YouTube video. Okay. Okay. So this is a YouTube video of Gazebo highlights. So really, in any field of robotics, you can use Gazebo to do your work. Okay, why Gazebo? Why do we need a simulator, and why specifically Gazebo? Because there are other simulators. So, fast algorithm development. With Gazebo, we don't need to wait for hardware, for manufacturing, wait for the hardware to be ready. We can just simulate our robot. We can take the CAD files, simulate a robot and run it in a physical environment that simulates friction, forces, masses, inertias, everything in a really accurate dynamic environment. So we can go with software development faster, and we don't need to wait for the hardware to be ready. Fast prototyping. Again, we can design a new hardware feature, like for us, if we design a new gripper for the robot, we don't need to send it to the manufacturing, get it back, have another revision. We can just plug it into the Gazebo environment and try it. Just try it, and really fast. So fast prototyping is a really good thing. Run test. We can have deterministic tests in a physical environment. We can run tests over and over and over again, the same test with the same environment. We don't need to drag the robot around, put it in the start place, send it again. Just run the test in the Gazebo environment, just save time. Again, physical engine. The Gazebo simulates a real world. So we can have very complex environments. We can have friction, we can have masses, inertias, forces, moments. Everything is simulated in the environment. It's an ODE engine. Very accurate and efficient. Sensor integration. We can insert cameras, LiDARs, any sensor you can dream of. We can have it in the Gazebo environment. You'll see later how we do it. ROS integration. We develop in ROS, so Gazebo is the right choice for us because there's a very strong relation between ROS and Gazebo. There are packages that communicate between the ROS environment and the Gazebo simulator, so it's very easy to run the same code you run on your real robots with the simulator environment. It's open source, so there is a community, so people contribute to the community, and you can take stuff you need and contribute yourself. So you can have a lot of stuff that you don't need to do from scratch. I'll show a little bit about the robot and joint state. This is our robot in the showing in ARVIS. ARVIS is like a GUI for ROS. You can visualize stuff. So this is a robot, and these are the moves that you can do with our robot. Two motorized wheels at the front, two caster wheels at the back, lift that can go up to 3 and something meters, and grippers that can take from both sides, so you can rotate it, and you'll see the fork going out, taking a wheel, going back inside. We define a coordinate system for each link or for each joint in the system, and we can easily have the forward kinematics of the robot and of the links. So I can know if I put a side camera here on the gripper and I want to know the relation between the side camera and the base link, I can easily know it, and it helps us a lot in doing stuff accurate. So these are all the moves of our robot. How do we create a robot in the Gazebo environment? First thing to do is take our CAD model, if it's SolidWorks or any other CAD environment. We want to bring it to the Gazebo environment and keep all the masses, inertias, center of mass, everything. So we'll have the most accurate simulator we can have. So this is the first thing to do. Gazebo works with URDF files or SACRO files or SDF files. It's just a framework to configure a robot. Collision and visual models. Gazebo define few models for a robot. Visual model is what you see. Collision model is the models that Gazebo do the calculations of collisions and other physical calculation.
Does
So
it support also weights and balance? And,
yes.
yeah.
Yes. Everything is accurate and modeled. So this is the visual model of a robot, and this is the collision model of a robot. So collision model, because we want to reduce computation and ease on Gazebo, we do the collision model simple. So it's just really simple shapes, like boxes or round spheres, and it's easier for Gazebo to calculate the collision if you have a few robots in an environment and you want to know the collision between a robot and a box or a frame or a shelf. So we make it simple. You can look on the gripper side. We have more details because it's the important stuff here. We want to know how we take the box and all that. So here more details. Here it's a lot simpler, just a convex hull of the robot. We can add sensors. Here you can see our small robot with fork over here. The blue thing is a LiDAR scan. LiDAR is like a laser scanner in 2D, so just a slice of scanning. And you can see when the LiDAR is colliding with the shelf, you won't see the rays. So with that we can do navigation, we can have a map of the environment, collision avoidance, lots of stuff. And here you can see the camera of the robot. This is the camera view at the moment. You can see here a QR code on the flow that helps the robot navigate and localize itself in the warehouse. So lots of QR codes over here you can see. And the robot localizes itself using those speakers. We can add plugins, so we have the Gazebo API open. We can write our own stuff. Plugin for make the light green. It's possible, everything is possible. Just use the API, write your own plugins. Very useful. The last thing to do is build a Gazebo world. You saw the shelves and everything. Just depends on your application, but you can build any world you want, and you can define the properties of the world. You can define the friction of the ground, and you can define how strong the sun is. So everything is possible. Everything is in your hands to model. This is a robot you'll see driving around. This is what we do in Caja. With our robot, like you saw in the demo, we do the same stuff in the environment of Gazebo. We focus mainly now on the driving control and how the robot localizes itself. So you see it going around a bit, taking the lift up, rotating the gripper. So this is really just like the same code that we run on the real robot. Same in the Gazebo environment. Lift is up, taking turns, going in the aisles. We can do a lot of tests like this, and finally, when we're ready, we can go to the real robot and know that everything is quite the same results. That's it. Questions?
I have a couple questions. First of all, about the accuracy of the simulation. So there is a physics accuracy, that is, for example, if you have this machine which is quite heavy, it can have an inertia, so it can be, in real world, it can be hard to stop it when it is moving. And what about the simulator as example? So how accurate is the physics?
It is accurate. If you take the CAD model with all materials defined properly, you can take center of masses, inertias matrices, everything from the CAD model, just convert it into Gazebo files, URDF or XACRO or SDF.
What about sensor accuracy? So for
also
example,
everything depends on you.
In the real world, you have noisy sensing.
You can define noise, Gaussian noise, whatever you want.
I see. Okay, so
just depends on you. Everything is open. you can model everything very accurate. You will get very similar results.
My second question, I've heard about OpenAI Gene. So it's somewhat similar in spirit simulator developed by OpenAI for software training.
Okay.
So do you aware of this simulator, and if yes, can you compare them?
No, actually I work only with Gazebo because of mainly because of the ROS connection. So yes.
Well, does Gazebo work with car manufacturing robots that manufacture cars? The arm.
Yes, the Epic in place. There is another simulator that calls Movie. It's mainly for arms and arms manipulators and indoor kinematics of arms. You can work together with Gazebo.
And And second question: what are what companies use Gazebo? What companies use Gazebo?
Not sure, but a lot of companies, I guess. Not sure.
So
specific names.
you can simulate the amount of load, for example, Amazon would have, fulfillment would have, their warehouses would have. You can simulate what the robots would have to do. Let's say you were doing something for Amazon. Would you be able to? You can simulate all the specifications. For example, the Amazon warehouses. You can simulate stuff they would have to.
Sure. In a specific one, you'll need some computation power, but yes, everything is possible. Multiple robots, complex environments.
What results are you expecting to get from a simulation when building one? What?
Model or?
Well, it's not a perfect model, and if you tune controller or PID controller, I don't know, you will have some differences, but you get quite similar results. And
in terms of collisions, other results?
Yes.
Many collisions?
Yes.
Regarding the AVIVs that you showed in the beginning, first of all, when do you decide to visualize an AVIV, and how easy is it to take the model you made for Gazebo and visualize it in AVIV?
It's the same model, the same. ROS have a package that's called description, just a description of a robot. If you do it well, you will have a good description of your robot, all joints, links, everything in the environment. You will see the same thing, but ours is only visualization.
Yeah,
you cannot do physical stuff.
Yeah, I know.
So
But
it's really the same file.
Yeah.
The same description file.
Is there a market for components that can be bought, algorithms, components?
It's open source. You have a community. For example, if you want to put a camera in your model, just go to the Gazebo website and look for the camera plugin.
Commercial companies that provide support or custom-made model or whatever?
Well, I can answer that.
Yeah, sure.
We've been last couple of weeks ago to OSRF, the Open Source Robotics Foundation, and if you're interested, they are actually doing some specific work if you need. They take some, one of the business models is by taking specific work for companies or people that need some plugins or support, and they will do it for you for a price.
But what was the name?
OSRF, Open Source Robotics Foundation. They will do.
Can I ask a non-technical question?
Sure.
As someone that I'm guessing you're fairly familiar with ROS and Gazebo and these different tools. In Israel, is there much demand for that kind of stuff? Are there people that say, we need someone that knows Gazebo?
Yes, we need someone. Yes.
More and more.
Yes, it's going outside of the universities to the industry. Yes, definitely. Robotican, who was here in the last meetup, Cognitive, lots of companies. Yes.
What is the discrepancy rating? Discrepancy.
I didn't understand.
What is the how? Is there any how much discrepancy is there in the system?
What type of discrepancy?
Yeah, like for example, the processing discrepancy, or like when the system is processing all the information and data. Is there any is there discrepancy? How?
As I said before, it really depends on the way you model the robot and the way, so that's basically the discrepancy. If you have a sensor with a certain field of view, let's say 25.5 degrees, and you model it as 25 degrees, this would be a discrepancy, but it's pretty accurate.
So there is some sensors, for example, have problems with black objects and specific materials. I'm pretty sure there will be some problems for that, but otherwise it's fine. I would suggest to continue the questions. Thank you very much.
Let's